Lesson 3.3 Basic Functions and Equations. We're going to take a look at a lot of different graphs today and talk about how we would label them and describe them. First of all, when we have dealt with graphing in the past, we have the origin, which is the point where two axes intersect. It's called the origin. The origin is also identified as the point 0, 0. So we've talked about this in the past. This is not new for us. And again, that would be right there. Now you have all these things in your notes, but I'm just going to put words to it so it may benefit the process of you learning it. Quadrants. Okay, again, to define what quadrant we are in, we already know some qualities, so let's validate those qualities. Quadrant 1, 2, 3, and 4. It goes counterclockwise. Here we have the origin highlighted as described in the previous vocab word. We have everything in the first quadrant as being a positive and a positive. So x and y values are positive. Second quadrant, we have negative x values and positive y's. Third quadrant, negative x's and negative y's to put us down there. And then fourth quadrant, which means positive x's, negative y's. A linear function, a function whose graph is a straight line and can be written in the form y equals mx plus b, where m and b are constants and m cannot be 0. In other words, your slope cannot be 0. So we have an example given. There's many examples. Let's talk real briefly about what would it mean if m was 0. So if I had a slope of 0, I would have an equation like this: y equals 3. Now, y equals 3, that equation is like that. I'm going to check on this one. I'm having a little bit of difficulty interpreting the m not equal to 0 part. So I'm going to come back to this one and make sure that it's actually correct. So let's move on. Quadratic function. A quadratic function, a function whose graph is U-shaped, curved, okay, so it's important it's a curve, not a V shape, that may open up or down depending on the sign of coefficient A, and can be written of the form. And there's our form where A and B and C are real numbers and A cannot be 0. That is true. A cannot be 0. If that's 0, then we have basically y equals bx plus c, which is linear, not quadratic. So again, here's an example. Notice it's U-shaped and not a V shape. That makes it parabolic. Then a parabola is a graph of a quadratic function. So this, as I mentioned, this quadratic function is also called a parabola, and that would be called a parabolic function. Next one, we have a cubic function, where now we have this cube at play, and again, a cannot be 0, because if a was 0, it would knock out that cube and it would just give you a power of 2, therefore making it quadratic. A cubic function looks a little bit different, so if you notice, it looks like half of a parabola going up and half of it going down. So it kind of changes directions as it goes left to right. So it looks like it's going to be an upside down parabola, but then all of a sudden it curves upward. That is a cubic function. Absolute value function. An absolute value is this notation. Now this is V-shaped. Notice we said the other ones were U-shaped. Then it means that a U-shape is quadratic. A V-shape would be an absolute value function. So we have to be very clear on whether it's a V or U-shaped. So in other words, absolute value means everything becomes positive. So if I plugged in a 2, I would get a 2 out. If I plugged in a negative 2, the absolute value would make it a positive 2 again. So it becomes a V. Exponential function. A function that can be described by an equation of the form y equals a to x to some x power, and a has to be greater than 0, because again 0 would just make it anything to 0 to any power is just 0, so it doesn't become a function, it becomes a point. So here we have an exponential function. You see how it grows exponentially? And that's the power. That's why with the variable in the exponent position, it can increase dramatically. So a to the second power, or let's say 2 to the second power compared to 2 to the fifth power, that's a pretty big difference in values. So it increases very quickly. A radical function. Now here we have y equals the root of x. Alright, that's a radical function, and it looks like this. Okay, we cannot plug a negative number in because you cannot take the root of a negative number. It becomes imaginary. So notice it only starts at 0, 0 and goes to the right. Very important about radical functions. Reciprocal function. In other words, y equals 1 over x. Now with the variable in the denominator, that causes some strange things to happen. So notice how in the first quadrant we have this very curved, it doesn't cross over. You can't have an x value of 0 because then it's undefined. 1 over 0 is undefined. As you get to the negatives, you see how it curves almost like a mirror. And we would get this if we made an xy table. But here's just some quick views of different functions. Conjecture. Conjecture is a little bit of geometry here, but it is an opinion or a theory so formed or expressed, guess or speculation. Based upon what you see, you form an opinion. So what do you think after seeing what you've seen? This is a theory or opinion. Step in graphing the various functions is to make a table and plot the points and connect them. So this is a lot basically then of lesson 3.3, and the assignment will reflect you making a table, filling in points, and connecting the dots. But then as we do so, we want to be able to look at the graph and describe what the graph is and give it a name. Is it cubic? Is it quadratic? And so on. And then also being able to tell just by looking at the function itself. And this ends lesson 3.3.